All right, so wood foundations, and there's an entire subdivision in Hanover Park, Illinois, that I've seen all the houses in wood foundations. And if at first I look at this thing, and I have to say that, are you nuts? Wood rots. Why would you put anything wood across the or underneath the soil? Wood isn't as strong as concrete. Concrete is the strongest thing in the world. And then I started thinking about the weaknesses of concrete. It does crack. It does settle. It's weak when it comes to stuff like that. And if there's a crack or an opening, water's still going to come in, and we have to seal it, when that happens, all right? And it's cold. Heat transfers through concrete through conduction relatively quick and easily. So then you can't run conduit through it. You can't run wires and outlets. You can't put insulation in it. So we're bumping those walls on the inside just so we could add, moisture barriers and insulation barriers. There was some issues that come into play there we just don't want to have. So you start thinking about the wood foundations, and I'm like, okay, the more I'm thinking about it, there's some pretty good benefits from these sort of things. So let's look at how we're building it up. So they usually start with a 2x12 treated pudding that goes not on the earth, underneath there. We're going to end up having a pretty thick, I forgot the number, but I think it's more than 6 mils. But it's a pretty thick moisture barrier that goes underneath this wood and then goes straight up to the side. And that's going to keep all the earth and all the water from getting to the actual wood. Because even though it's treated, if it was sitting in water or would get wet, then it would definitely still rot. So we have to prevent that from happening. But it comes all the way up there, and it does get damaged, it does get ripped. Maybe somebody put it in wrong, didn't seal seams. There's always a possibility that water can get through. But if water gets through, you're going to know right away. There's not going to be a slow leakage. It's going to come in there, and you're going to see water stains on either the insulation, the drywall, or the studs themselves. All right. These are typically built out of 2x6 walls. Where it comes in there, it might be thicker, but 2x6. And remember, double the width of the footing where it comes in there. So that's why we have a 2x12, and then we build our 2x6 wall on top of that. It's all treated lumber underneath there, so it can handle small amounts. That moisture barrier that comes in there, so that moisture barrier does come all the way up and above the earth. And then this board on top of here is actually considered a sacrificial board, and it will rot, and it will need to be removed and changed out. I want to say probably every 10 years. It might last longer than that, but it's mostly to be protecting against physical damage from above and to keep water from coming in there. And then we put the siding on top of that. The benefits are, I got a place that I could stuff with insulation. I can make that basement pretty warm where it comes into it. I could run electrical lines, water lines in there. If we're below grade, it's typically going to be 55 degrees or somewhere in that ballpark. Always, as long as we're below the frost line. I don't have to worry about pipes freezing in there. And if something does shift, there should be some movement to allow some settlement that comes into play. And it's wood, so it's easily we can get in there to fix something and move it. I actually think it's a pretty good idea. And from what I understand, it is a lot cheaper than pouring concrete into those areas. So, but again, our job is to describe it. It's a wood foundation. Our job is to say, is it doing what it's supposed to be doing? And that it's holding the earth back and not letting water come inside. And if that's the case, then we're just going to describe and document what we find. And if somebody wants to buy it, that's completely their choice. We shouldn't be just making opinions or comments saying, oh, it's a wood foundation, so automatically it's bad. Just we call it out what it is and let people educate them as much as you can and learn as much as you can. But the more I've learned about this, the more I actually like it. And in our society, a little more defense for it, our home buyers, they want to get as big of a house as they can nowadays. That's just the majority populated belief, I guess. And so the builders, they want to give all this square footage. They want to give the biggest bang for the buck. So without making things dangerous, they're looking for cheaper alternative construction methods so they can give somebody that bigger home that they want and desire. They can make a bigger profit on the houses as well so they can stay in business. And it's a win-win-win all the way around. So we do have wood foundations. I do want you to be aware of that. All right. Cinder block, concrete masonry units. We kind of use those terms interchangeably. All right. Really, the only difference is the aggregate that gets mixed into. We'll call it concrete, I guess, for lack of a better term. You know, it's just the aggregate that's in there. So if we use cinders, well, then it's a cinder block. If we use concrete, then it's a concrete masonry unit. When we're building these things, but they're both basically the same thing. They're a figure eight shape that goes, up and down. The holes, anyway, should be going up and down, and we should be filling those openings or gaps up with concrete to make them solid. I know in above grade it doesn't happen very often, and I don't have any way to check it if it does. We did have CMUs underneath our porch up in the front, and they were not filled with concrete when we did our remodel here, and that was something that we ended up doing. Mixing concrete, pour it in there, put our anchor bolts on there, and we made it one solid concrete wall. I would like you to know the term CMU, that stands for concrete masonry unit, and then cinder blocks, I think it's more of a common. Nobody really puts cinders in the aggregate of the mix anymore to make the CMUs. All right. I want you to know something called a bench footing. So I know the title up here is basement lowered suspected, but really what I'm hoping you're catching on here is something called a bench footing. So original basement opening was here, but I wanted it deeper. All right, so we dug down, and now we made it more usable. Well, although you will see this, people will dig this foundation straight down. And depending on how they hook this together and tie it all in there, the biggest fear is for this footing to slide off or be pushed in, and we're actually going to be creating a kneecap. So to avoid that kneecap, what we do is we dig the earth on an angle like this, and digging it on an angle will prevent this from coming in there. Then we pour more concrete in here, and the main purpose of that concrete is to keep this footing from sliding in. Hopefully we're going to have a drain tile at this footing level, and because this is lower and the water table is going to work its way down, figure it's just going to slide right underneath here if it gets to that level. We need to be able to capture the lower footing as well and let that water go into a sump pit, collect it, and pump it away from the house. This goes around the entire perimeter, and when that happens, it looks like a bench. And that's how it got its name of a bench footing. All right. Two different types of, or two more terms that we're going to be using for foundations. One is called a raft foundation, and think of any sort of foundation or hole in the ground as kind of a boat. So if we're dealing with basements or crawl spaces, we're digging out a hole and water is going to want to go back into that hole. We need to prevent that, so that's where we come in with the raft and stuff. Slab foundations, we're pretty much pouring straight across on the top. As far as basements or crawl spaces, basements are intended to be for walking underneath there, and I'm going to go with the minimum height is 6'8". So as long as we're above that, or you'll find some references to 7 feet, 7.5 feet. I personally like things 8 or 10 feet when they're in there. But truthfully, if I could stand up, even if it's not that high, and I could walk in there, I'm calling it a basement. If I have to get on my hands and knees or crouch over, I'm going to call it a crawl space. Now, I get it. I could probably stand in some areas that you put Michael Jordan or, some other extremely tall person in there, and they're not going to be able to walk straight up and down like I can. Or even on the other side, we get somebody who's shorter, and they may be able to walk in areas that I can't walk in. Nonetheless, I don't think it's the end of the world if you call something a basement or a crawl space. So getting into the slabs, we do have 3 different types of slabs that you're supposed to be aware of. I'm going to hit all 3 of these, and then I'll come back to this one. So the first one is a floating slab, and then we have a supported slab, but this is a 2-pour slab. And then we also have a supported slab, but this is a 1-pour slab. Single pour slabs are called monolithic, and when we're in areas where slab construction is popular, this is probably the one that we're going to end up seeing. So let's go to the first slab. Sidewalks, driveways, anything that's floating on the earth, they're usually going to be above the frost line when that happens. They're subject to settlement or heaving if water gets underneath it. In buildings, in houses, our garage floors are typically going to be floating slabs. So our footings, and I'm talking about on attached garages, forgive me, not detached garages. So attached garages, we're going to build our footings going all the way around, and then inside there we're going to put a floating slab in there as well. All right. Supported slabs, even though on this one we're showing that it's on top of the foundation, and we do have areas where this is pretty common actually. I know the Chicago Housing Authority, they build all their construction this way. So on the outside what we're going to see is a cold joint, so that's going to be the top of the foundation here, and then we'll see the slab poured on top of it. It's not a defect, it's just it is what it is. The problem with that is the area in the middle is still floating. All right, hopefully there's going to be enough stone and undisturbed soils, but that's not always the case. All right, because this was dug out, especially in this area here, because they have to make an overdig, and it was put back in there. Usually you get sediment or sinkholes, for lack of a better word, underneath the slabs. And I've literally seen where these slabs have come down and you actually see them start to bend and they drop down and go back up on the other end. It's pretty amazing, you know, how much the earth can move. We have a few areas in the city of Chicago. It just so happens to be one of the highest, most sought after, most expensive areas is Lincoln Park, and this is no way of me trying to diminish the property values there, but there is a lot of settlement issues. But with everything, settlement issues can be fixed. You know, they could do mud jacking, they could do other items to go ahead and solidify the ground or the earth that's underneath those slabs so that they don't settle. All right. Single pour or monolithic pours, these are common in detached garages. All right. I visited my son down in Memphis, Tennessee, and down there they really don't have any basements at all. Everything's built on a slab. I think that's because they have a lot of bedrock that's pretty high, and you just can't dig through the bedrock. And that's a guess. I'm sure there's some areas that have basements, but most of this new construction I saw down there was a monolithic pour. So here, when they run the plumbing and everything else, they have to put all the plumbing, heating ducts, anything that they're going to run underground, they have to get all those items in there first, and then they go ahead and pour the slab. Now the bottoms of these footings here, the monolithic pour, this does need to be on undisturbed earth, so we can't fill it back in with stones or rock or anything else to raise it up. It needs to be straight clay or whatever the earth is going to be in here. The middle can be filled with stones and rocks, and typically there's going to be steel that's mixed in here so that the concrete stays together. All right. Monolithic pour, very common in detached garages in our area that we're going to end up seeing. Basement lowering of the bench footing, we saw that already. All right. A few more words. Bowing, bulging, leaning. You are expected to know these terms. You will be tested on them, and we should really be using them properly. All right. So leaning, typically there's not going to be any cracks that are going to be associated with it. These foundation walls should go straight up and down, all right? I know this drawing here, it's showing that there's a crack in there, but typically when something leans, the whole thing is moving as one piece, all right? Bowing, if you see it, that's going to be the horizontal movement. So if something is bowing, it's being pushed inwards or outwards when it comes with it. Bulging is going to think of that kneecap thing again. So bulging is a vertical displacement. So if we get the knee or that's pushing in here with the bulging, that's when we're going to use that term. Cold joints, anytime you have concrete that has cured or dried or become hard, that's known as, and then we pour more concrete on top of that, that's a cold joint, and you'll see definitive lines in there. They're not going to be a crack or anything else. When you start seeing shadows in the concrete, that's, I don't think they call it a warm joint, but that's where two different pours came in there, but yet the first pour didn't cure yet. All right, but cold joints, one is already cured. So reading cracks is a big deal here, and I am going to step up just for a second, and then I want to switch cameras here. So let's talk about reading cracks. This is probably going to be one of the more important things that our clients are going to be worried about when they end up seeing cracks in their basement floors, and what's serious and what isn't serious. All right. Now, you can always pawn this off on like a structural engineer if you want to, but in all reality, a structural engineer is going to be having the same handicap that you're going to have. The biggest problem with reading cracks or finding out how serious they are is knowing what we know, and more importantly, realizing what we don't know. All right. So if a house is brand new and the foundation is like 2 months old, and I'm starting to see some cracks in that foundation that have happened already, I think we could start being a little more nervous about things. All right. But if a house is, let's say, 50 or 70 years old, and we see cracks in the foundation, and pretty much everyone we're going to run into is going to have that, let's think about what we don't know, all right? Those cracks that happened, they may not have... Our entire screen is showing. I'm sorry about that. Perimeter edges are cut off. Okay. Let's see if I could zoom out a little bit then. There we go. Hopefully that'll make things a little bit better, so you can see these things. So getting back to reading those concretes. We don't know when that crack happened. If it happened 70 years ago, and what we're looking at is as bad as it's gotten, and it hasn't moved in 50 years, that's not a bad crack. All right. But if it happened 70 days ago, and things are starting to move, then it could be a serious crack or a bad crack at that point in time. All right. We just don't know. All right, so everything is done over time and distance. That's the only way to tell if something truly is serious or not. So if a crack has happened, it doesn't make it a bad crack. If the crack is still moving or the foundation is still moving, we have a serious problem and we need to stop that. All right.